In this cast, we're going to be looking at acceleration. Acceleration is a quantity that describes how fast is changing. Fast changes. It's defined as the change in velocity divided by the change in time. So in terms of symbols, we have delta v vector over delta t. The SI unit for acceleration is velocities meters per second per second. And if you clean this up, it would be meters per second squared. Okay, that's the SI unit for acceleration. So it's not a simple concept. It takes a little while to get used to what acceleration is. One thing that you must note is that we can have big acceleration even at very small speeds. Okay, because acceleration has nothing to do with speed, really. It has to do with how fast the speed changes. Okay, so in order to talk about acceleration, I'm going to use this example here. We have a train going from station A over here, going in a straight line, speeding up, going at constant speed between 5 and 7 seconds. Okay, if it goes at a constant speed in a straight line, we call that uniform motion. Okay, so uniform motion is motion that when an object travels at constant speed and direction. So both of these have to remain the same, and we have uniform motion. So this basically means that acceleration is equal to 0. Okay, so let's look at acceleration. In this case, if we start at time 0 to time 1, we are adding 1 meters per second. Okay, to go from 1 to 2, we are also adding 1 meters per second. To go from 2 to 3, we're adding 1 meters per second. Notice how the distance increases between each second. This is because the speed is increasing, so we are accelerating. So in this box here, we should note that v is changing by +1 each second. Okay, so that's in this block here. So therefore, what this means is that the acceleration, if it's changing 1 meters per second, so it should make sense that the acceleration is 1 meters per second squared. Okay, let's look at over here. Here, to go from 5 to 6, we're going 0. We're increasing by 0 meters per second. And here the increase is also by 0 meters per second. So this should make sense that here we have acceleration of 0 because we are not increasing our speed or changing direction. Now in this case here, okay, we're always traveling at 4 meters per second, but we are changing direction. So we are accelerating in this area, in this part of the track here. So even though it's the same speed, okay, but it's changing, oh my god, changing direction. Okay, so acceleration in that part here, acceleration is not equal to 0. Okay, over here at 11 to 12 seconds, we're going 4 meters per second to the left, and so to go to 4 meters, that's a change of 0. From -4 to -4 is a change of 0 as well. Okay, so what's happening down here? This is going to be super important. As we go from 4 meters per second here to -3 meters per second, what must we do to go from -4 to -3? Well, we must add 1, because -4 plus 1 is -3. So to go from -3 to -2, we also have to add 1, and we're adding 1 here, and we're adding 1 to get to 0. Okay, so even though our velocity is negative, because we're adding one each second, in this case, we still have positive acceleration. This is not an easy concept to get the first time, but here, acceleration is positive even though object is moving to the left. Object is moving to the left. Okay, so over here it's moving to the right and acceleration is positive because it's speeding up in the positive direction. Here acceleration is still positive because it's going to the left and slowing down. Okay, so that could be quite confusing. So let's have a look at the direction or the sign of acceleration. Super important that we understand this. So let's say the object is moving to the right. Okay, and it starts with a velocity, so v initial is 5 meters per second, and then the vector is longer here, so v final is 10 meters per second. Okay, so the easiest way to think about which way things are accelerating is which way would you have to push this box in order to get it from 5 meters per second to 10 meters per second. Well, if you're on this side pushing it this way, okay, you're pushing it to the right. And so if you push right, then you will be accelerating, the acceleration would be positive. To see this, we have delta Vx is equal to final velocity, which is 10, minus initial velocity, which is 5, would give us a change of velocity of 5 meters per second, positive 5 meters per second. So in this case, we're pushing to the right, acceleration is positive. Okay, let's go if the object moving is to the right but slowing down. So the v initial is 10 meters per second, and now v final is 5 meters per second. Okay, which way would we need to push in order to go from 10 meters per second going to the right to 5 meters per second going to the right? Well, the person would need to be on this side of the box to slow it down. So the person here is pushing to the left. So we would guess that the acceleration would be negative. And in fact, if we did delta Vx is final velocity is 5 minus initial of 10, gives us a change of velocity of negative 5 meters per second. So indeed, because we're pushing left, acceleration here is negative. Okay, we have two more scenarios. Let's say object is moving to the left and v initial here is negative 10 meters per second. Here v final is equal to negative 5 meters per second. Okay, so if we're going to the left a negative 10 meters per second and then going to the left at 5 meters per second, which way would we need to push? Well, we need to slow this thing down, so we would need to be pushing to the right to slow it down. So we should anticipate a positive acceleration. Let's check. Delta Vx is equal to the final velocity is negative 5 minus an initial velocity of negative 10 gives us negative 5 minus 10 gives us plus 5 meters per second. Okay, so the change in velocity is positive, therefore we have positive acceleration. Okay, and finally here, let's say we are going v initial of negative 5 meters per second and then v final of negative 10 meters per second. In order to do this, we would need to push to the left. Okay, so we should have a negative acceleration. Let's check. Delta Vx is equal to final of negative 10 minus an initial of negative 5 gives us a negative 5 meters per second. So the change in velocity is negative and we have a negative acceleration because we're speeding the box up to the left. Okay, so what's important takeaways here is that the direction of acceleration has nothing to do with which way the object is moving. It has more to do with which way the velocity is changing. Okay, and the best way to think about it is which way would we have to push the object in order to give us the desired change in velocity, and that will give you the direction of acceleration.